This is a video on naming cycloalkanes. So if we start with this cycloalkane, again a cycloalkane is something that is ring and shaped. So here's our ring. We have 3 carbons in a ring. 3 has the name of prop. They're all single bonds, so it's propane, and they're connected in a ring, kind of like a circle, so it's called cyclopropane. Let's look at this next one. This next one has 1, 2, 3, 4 carbons in a ring. The prefix or the stem name for 4 is excuse me, bute. Single bonds ane. There's no branches, so it's cyclobutane. Cyclomene is connected in a ring. It's not a straight chain. This next one has 1, 2, 3, 4, 5, 6 carbons in a ring. A lot of times organic chemists are lazy and they write them more as stick structures. Those angles indicate carbons. So that structure is cyclo because it's in a ring. And 6 is hex. They're all single bonds. It's ane. But now we have some branches. We have 1 branch, 2 branch. They're both methyl groups. So I know it's going to be dimethyl. So at least squeeze dimethyl in here. And now I have to count where they are. And I would just start counting at a branch. You could go 1, 2, or you could call it 1, 2. Either way, it's the same. So it's 1, 2 dash dimethyl cyclohexane. Huge names. Let's look at this next one. This next one has 1, 2, 3, 4. So I know the base name is going to be cyclobutane. Now I have 2 branches, and you have a chance to number correctly and alphabetize correctly. So that one's ethyl. That one's methyl. We have to alphabetize. So that one goes first. I would call that 1 and that 2. Make sure you put them in order. Don't start numbering that way because you won't get the best numbers possible. So I'd call it 1 dash ethyl dash 2 dash methyl cyclobutane. Let's look at this next one. It is a cyclohexane ring. So cyclohexane. And we have 2 branches. They're both coming off the same carbon. So 2 branches is dimethyl. And we would just call that 1. So I would call it 1, 1 dash in there, dimethyl cyclohexane. And that di means you need to have 2 numbers here, even if they are repetitive numbers. So there's a lot of redundancy built into this system. Let's look at number 15 here. We have 1, 2, 3, 4, 5. It looks like the pentagon. It is a pentagon, people. So we'll call it pentane, all single bonds in there. Cyclo, I never leave enough space to write this. 1 branch, I think is supposed to be there. And that's methyl, so we'll call it 1 methyl cyclopentane. Some people might just call it methyl cyclopentane since there's nothing else on there. It would indicate that it defaults to the first position. So let's see if you can draw some of these structures. Let's go back up to right about there. Let's read this. So if we had 1,3-dimethyl cyclopentane, so cyclopentane is going to be 1, 2, 3, 4. I got to squeeze this in here. There we go, and 5. And I just like to call the first, the top one 1. And I'm going to count this way because I'm running out of space on the right-hand side of the screen. You could count it clockwise, which actually makes more sense. So there's a methyl group there, and 1, 2, 3, and there's a methyl group there. I left out my H's. Let's look at this next one. 1, 2 dimethyl cyclobutane. So we got a square, cyclobutane. I think I'll call this one 1, 2, 3, 4. So there's a methyl group, and there's a methyl group. This next one, 1, 3 dimethyl cyclopentane. We'll draw our little housey pentagon. And I think I'll call that one 1, 2, 3, 4, 5. Methyl. That's a 3, believe it or not. Let's look at this one, 1, 2 dimethyl cyclobutane. Again, it's a square. I'll call that one 1, 2, 3, 4. You can't switch up your numbering like that. And there's a methyl, and there's a methyl group. Let's look at this last one. 1-ethyl cyclopropane. Ethyl has one more carbon in it than methyl. So 1-ethyl cyclopropane, 3 carbons. It's a triangle. 1-ethyl, it doesn't matter which one you call 1. I think I'll just call that one. And there's an ethyl group. I'm just bending it way out of shape out there. I hope you learned something from naming cycloalkanes. I hope you visit the next one, which would probably be on alkenes and alkynes.